Hi guys. Sorry I'm not there, but I should be there tomorrow, so that should be good. Today I'm going to review what we've done so far in chapter one because we have a quiz. I have printed, and hopefully you have with you a review sheet that we're going to do in class. So I'm going to go over it. As I go over it, I'm going to say pause this, and then I want you to try the problem. And then after everybody's had an opportunity to try, then you can unpause, and I can go over it and you can check your work. If you're not sure how to do it, then just make sure you follow along as I go over it so you know how to do it. After we complete this, after the video, you'll get one almost exactly the same. It's a mirrored one. So mirrored means same type of problems, different numbers. So if you need to look back on this to help you figure out how to do it, do that. This has space. So if you need to write in here little hints to yourself how to solve these problems or show your work, you can do that. And then the answers can go into the shaded region. So I'm going to go through this with you, and hopefully you are following along and you're trying every problem and doing your best. And then you'll have time to practice this on your own. And the quiz will be very similar. So if you feel confident with this at the end, then you'll be fine when we do the quiz. I'm going to turn on the hover cam so I can do these problems with you, and we'll get started. Okay, so I'm not sure how clear this is on your screen, but you should have it in front of you so at least you can follow along. I'll try to zoom in a little bit. I know it's blurry on my screen. I'm going to zoom it slightly blurry on yours. In this unit so far, we're talking about functions. And remember, a function has one input, and for each input, there's one output. We've talked about plugging into functions, that's evaluating. We have also practiced graphing and identifying key points and identifying the domain and range. So that's what I'm going to cover in this review. That's what will be covered on your quiz. So this first problem is finding the point of intersection. So it says use any method to find the point of intersection. So I'm just going to kind of remind you how to do that, and then give you an opportunity to do that, and then I'll go over it. But remember, when you're finding the point of intersection, that's where two functions cross each other. So you would want to put this first one in your y1, and you'd want to put the second one in your y2 in your graphing calculator. And then remember, you have two options. Option 1, you can refer to the table. Option 2, you can use the intersect function. You can do your second trace and choose option 5 and do that. So what I want you to do right now is give that a chance. So go ahead and pause this. Attempt to find the point of intersection. Occasionally you could have 2 points of intersection. So make sure you're finding all the points of intersection if there's more than one. So go ahead and pause and give that a try. And then when you're ready, push play and I'll go over that problem. Okay, so let's go over this. So hopefully, and I know you may not be able to see my calculator very well, but at least listen to my steps. So make sure we're putting in our two functions. We have 6x minus 10, and we have negative 8x plus 18. If you can see that very well. And then we can hit graph. I always like to hit graph so I can see how many points of intersection we have. And we have 1, so we're only finding 1 point. So if you're using the table, remember we just hit second graph. And we look on the table for where the y values are the same. I'm going to go back to the graph real quick. Make sure you're kind of being strategic about how you look at the table. I can tell the point of intersections on the positive side, so I don't need to scroll along on the table my negative x's. So when I go back to my table, I'm in the negatives. I know my answer's not there, so I can start to go down. And I'm looking for where my y's are the same. And it's right here. I have 2 2's. So that tells me my solution is 2, 2. 2, 2. And I only had 1. So I'm going to go back real quick and show you the other option you have on how to solve it. So remember, you can do second trace. And you want to choose option 5. It says intersect. And then remember, from there, you just hit enter, 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 and it will give you the answer. And it gave me 2, 2. So those are your two options for solving for finding point of intersection. Remember, if there were 2 points of intersection, you would have to do that process one more time. You need to move the little cursor that shows up on the screen close to whichever point you're finding. Okay. So the next set of problems 2 and 3, are very similar. These are evaluating functions. So you're going to be plugging in. So if you need to remind yourself, and make sure you plug in using parentheses. So everywhere there's an X, you're going to replace with a parenthesis and whatever input you're provided. So I'm just going to kind of do this first one right now, and then I'm going to ask you to try some of these other ones independently. So this says f of 3. So that means in this function, everywhere there's an x, I'm going to put a 3 in parentheses. So I have 2, here's an x, so in parentheses I put 3, and then the square. Plus 6, there's another x, so in parentheses I'm going to put the 3, and then minus 8. And you can type that into your calculator and just get your output. We've plugged in the input, we want to find the output. Remember, if you're using your calculator, we want it on the solving screen. So we need to clear out, get to this solving screen right here, and type in what we see. Just as we wrote it. 2 in parentheses 3 squared plus 6 in parentheses 3 minus 8, and then we just get our output. So this one should be 28. So that tells us f of 3 equals 28. 3 was our input, 28 is our output. So right now I'd like you to try the second one. Go ahead and pause that. Actually, go ahead and try 2b and then 3a and b. Number 3 is a square root. So to get the square root, just hit second x squared on your calculator and then plug in your number. So pause the video now so you can try that. And then when you're ready, come back and I'll go over it. Okay, let's go over these. On this one, we're plugging in a negative. So it's very, very important that when you plug in, you're using that parentheses. If you don't, you could get the wrong answer. This is a negative 5 we're plugging in. So 2, and then negative 5 is in the parentheses for both x's. So you're typing in essentially the same thing, but instead of a 3, we're plugging in a negative 5. So 2 times negative 5 squared plus 6 times negative 5 minus 8. And we get 12. If you got a different number, there's a good chance you didn't put your negative 5 in the parentheses with the squared outside. You should get 12. Okay, now down below, this is a square root function. So when we plug this in, both the x minus 2 are in the square root. So make sure you remember that when you plug in. So we're doing the square root of 11 minus 2 on the first one. 11 minus 2 is 9, so we're doing the square root of 9. You're not very confident with your square roots, you can type this in. The square root button is right in blue, if you can see it very well. It's in blue above the x squared, so that means we hit second x squared, and then it should come up. And then we can type in 11 minus 2. I'm going to close my parentheses, and it gave me a 3, because the square root of 9 is 3. I just noticed I have the wrong numbers right here. That's okay. So we got 3. Then we're going to plug in a negative 2. So same equation. We're plugging in negative 2 minus 2. Negative 2 minus 2 gives us a negative 4. We're taking the square root of negative 4. I don't know if you remember from our lesson the other day, mixing up my days. The other day we talked about domain and range. You can't take the square root of a negative. So this actually has no solution. If you were to type this into your calculator and you do the square root of negative 4, it will tell you non-real answer because you can't do it. So if that happens, you can just say no answer, no real solution, exactly what the calculator says, non-real answer. But it's not possible because you can't take the square root of a negative. So that can happen, that certain inputs don't work. So that's why we talked about domain and range, because sometimes there's values that don't work. Okay. So to the next page, this is covering when we talked about investigating functions. So to investigate this function, the first thing we're going to do is graph it. So I've provided you a graph. Put this in your Y1 on your calculator, and then you want to go to your table to find which points you want to plot. After you've made an accurate graph, then you want to go through and see if you can identify these key points, identify the domain and range, and identify the vertex. Remember, when you write your domain, we're talking about x's. So your lowest x to your highest x. Remember, x's are left and right. And your range is your possible y's. So your lowest y to your highest y. So what I'd like you to do right now is pause this and attempt to graph this and answer all of these questions. When you think you've got it, we can come back and go over it. Okay, so when you graph this, we're putting this parabola, this should be a graph of a parabola. We're putting it in our y equals. We clear out anything we have in there, and we type the equation as it appears, x squared minus 2x minus 8. And you can hit graph, and it's a parabola. So we can see that the parabola has some on the negative, on the positive. We want to make sure we get enough points so we can see a good picture. So we need to look at the table. We hit second graph to see the table. And then we can start plotting points. I'm going to start at -3. Now it says -3, 7. My graph goes to 6, so I might just make it a little off the graph just so I can get a good picture still. Let's scoot this over and stop here. So the first point is -3, 7. And then go -3 up 7. My next point is -2, 0. -1, -5. 0, -8. Again, this is going off this graph, and that's okay. We can still kind of approximate. We have 1, -9, which would be one below that. 2, -8. 3, -5. And I'm going to go at least one more. 4, 0. And then we have 5. So even though it goes off, I can still see what I have. And this point was 1, -9. I'm going to mark that because that was an important point. It's my lowest point. And I'm going to connect my dots. Parabolas are curved, so make sure you give it a nice curve. And this will keep going. Just because I stopped there doesn't mean that's where the graph stopped. That's just where I stopped plotting. Because if you look at the table, it'll keep going and going and going. We just don't have room to keep going. So we have this nice picture of this parabola. And now we can identify some key points. Let's see if turning on a light will help. Okay, so the first thing we want to do is identify any x-intercepts. Remember, x-intercepts are where the graph crosses the x-axis, and we have 2 of them. We always label our intercepts or identify them as an ordered pair. So that means you have 2 values, the x and the y. So the x is -2, 0. And the second one is 4, 0. So we list both of them because we have 2 places the graph touches the x-axis. The next one is the y-intercept. Remember, the y-intercept is where the graph touches the y-axis. This one, if this kept going, we could see where it intersects. That the y-intercept is always when x is 0, so it's always a 0 and then whatever the y value is. In this case, it's -8. You can always find the y-intercept on your table because it's always when x is 0. So you can always go to your table and look if you're unsure. The next one is identifying the domain and range. So remember, domain is your x values. X's are left to right. So we always want to find the lowest one. Now, if you're looking, as I go left, this graph isn't going to stop because it has this arrow. So we may not see the point, so it can keep going, going, going. It will never stop. So remember, if the graph never stops, that means it goes on to infinity. And since it's going to the negative, we say negative infinity. And it's doing the same thing to the right. It keeps going, going, going until that's to positive infinity. Remember, that domain is always the domain for a parabola. Every parabola will have that exact same domain. The next one is the range. And range is your y values. Remember, your y values are up and down. So you always start lowest. We want to find the first y value. And it's right here. This is our first y value. And this is negative 9. So the lowest y value is negative 9. And then we want to see how high it goes. As we go up, this graph will keep going up, up, up. It never stops. So it goes from negative 9 to infinity. That's essentially what you're saying, is where the graph goes. So the x's go negative infinity to positive infinity. The y's start at negative 9 and go on infinity, go on infinitely. And then it's asking us to identify the vertex. Remember, the vertex is the place where the graph changes direction. So this graph's going down, 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 down. And then when it hits this point, it's going up, up, up. So that's your vertex right here. And that point is 1, negative 9. And then it's asking, is that vertex a maximum or a minimum? So since this is the lowest point on the parabola, that vertex is a minimum. So if you need to kind of pause this right now and write anything down that I just went over, make any corrections, go ahead and do that. If you want to ask people around you some clarifying questions, you can do that as well. But I'm going to go to the last page where it really focuses on domain and range. I'm going to move this out. Okay, so this is asking us to identify the domain and range. So I am going to kind of remind you what to do and then give you a chance to see if you can solve it on your own. We put an X here, and then we fill this in for domain. So you're finding the lowest X value and then the highest X value. Remember, domain is like left to right. The range is your Y values. So we put the lowest Y value to the highest. And remember, range is your up and down values. So you're looking up and down. Same thing down here, but it's a different type of function. And then remember, you're answering if it's a function. Remember, you check using the vertical line test. Am I only hitting one point at a time? If I am, it's a function, and we say yes. So go ahead and pause this now and try to complete these two, and then I'll go over them with you so you can check your work. Okay, so we're identifying our domain, which is left to right. The domain is our X values. So as we're coming from the left, our very first X value is right here. This is your X, it's negative 3. So it goes from negative 3, and then we want to see where it stops. And our last one is right here when X is 2. So our points on this graph go from negative 3 to 2 on the x-axis. They don't have to touch the x-axis. We're just using that as our guide. Our range is our y values. We want to find the lowest one. So as we're going up the y-axis, the very first y we see is right here at negative 3. That's our lowest one. And then we want to see how high does it go. So we keep going up until the graph stops, and it goes up to 4. So this graph goes from negative 3 to 4 on the y-axis.
And then to check if it's a function, you're just looking, does with the vertical line test, do I hit 1 point at a time? And yes, I do. There's no place on this graph where I hit more than 1 point. So yes, this is a function. So when you have a graph with two endpoints, you will always have two nice numbers for your domain and range. The second one is the graph of a parabola. Again, we set up our domain the same. We're saying our x's, our range is our y's, lowest to highest for both. So looking at this, this is a parabola. And if you remember what I said about parabolas, they always have the exact same domain every single time. This will keep going to the left and keep going to the right. So the domain is negative infinity to positive infinity because it will never stop to the left or to the right. The range is different though because it does have a lowest point. This graph has a minimum. So we have to find the lowest y, and that is right here, right there, when y is -4. And it will keep going up, 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 up. So that means it goes to infinity. And then is this a function? Yes, parabolas are always functions. So if you need a minute to kind of jot any of that down, go ahead and pause this. You want to ask people around you how I got any of that, you can. But what you'll have next is a review for you to try all by yourself with problems almost exactly like this. The numbers might change, graphs might be different yet similar, and you're just attempting the same skills to make sure you can do it and apply it to new problems. Don't be afraid to help each other out. Don't be afraid to reach out if you need help. But this is what will be covered on your quiz, so make sure you're prepared. So I should be there tomorrow. So if you have questions before the quiz, I can go over things with you. We can go over these problems again if you need to. Not too crazy in depth. Like I'm not going to redo every single thing, but I'll definitely take questions and I'll be able to help you out before we take our first quiz. So try your best. Do what you need to do. If you have anything missing after you finish this, get that taken care of because Tuesday is the first day we put in grades. So I want to make sure everything's up to date. Let me know if you need anything, and I will see you soon.